Alright, so this is Vodcast 2 of Unit 4, and we're going to be looking at contour lines on topographic maps. And you should have done a lab previous to watching this podcast that kind of goes through what a topographic map is and how they're made. A topographic map is just a map that shows changes in relief, alright, or changes in elevation, which is known as relief. And you can see these brown lines and they look a little odd, but if we were to take this landscape and flip it to the side and actually see what it looks like, you can see that there's a river valley here, there's a large hill and a ridge, even a volcano or caldera here, some steep sided cliffs and some less steep sides. Got the water down here. So all of those changes in elevation, those features, are actually represented by these contour lines on this topographic map. And we're going to be going through these 5 different plots on here and showing how you can determine their elevation. Again, the whole purpose behind this is so that we can understand the maps that we see when we're working with plate tectonics. So keep that in mind. So again, these brown lines are called contour lines. There are actually 2 kinds of contour lines. There's the regular contour lines here that are light brown, but then there's also contour lines with the numbers on it. These are known as index contours. Just like an index of a book tells you the page number, index contours tell you the elevation of that line. And each point that is on this line is that elevation. All right? That's what contour lines are. They're lines that connect points of equal elevation. If you do get close to the water, to sea level, you can actually have blue contour lines that show depth below the surface. We usually don't see those much, but each of these lines on here is showing where points of equal elevation are. So all the points on this line are a certain elevation, all the points on this line are a certain elevation, and so on. But first thing we need to really do before we can tell what the elevation of these different lines are is to know the contour interval. All right, the contour interval, if you look down here in the key, I took it out, it's blank. What you need to do here is figure out how much does each line go up or down by an elevation. And we can see that we have one index contour line here of 0 feet. And the next one that we know the elevation of is this one at 100 feet. Well, if there are 5 lines from one index to the next, so 1, 2, 3, 4, 5, that's the norm. That means in this map, and it's specific to each kind of map, each one of these is 20 feet. It could be 0, 20, 40, 60, 80, then 100 feet. You should always double check yourself, because if you get this wrong, then the elevations are going to be way off on the rest of it. So that means if I cross in a contour line, I'm increasing my elevation by 20 feet, or possibly going down. We'll get to how you know later. So let's just jump right into figuring out A. So you can see that A is sitting right on this index contour line, which is going to make this one very easy to determine. All we need to do is follow it around until we reach the number. All right, so A is 100 feet. Pretty straightforward. And we could also then go to the next one. All right, B. All right, it is the next contour line. The question, though, is, are we going uphill, which means we'd add 20 feet, or are we going downhill, which would we subtract 20 feet? A couple ways you could think about this. One, you can see there's a stream here, and you should also have gotten with this note guide is the rules for contour lines, and you can see that these contour lines are V'ing as they go across a river or a stream. They always will point upstream, so this is uphill. So we know we're going uphill. Plus, all right, as you can see, as we get closer and closer to this bullseye, center of this bullseye, for the most part, this one's a little odd, but if we were to use this one over here, a bullseye is represented as a hill. We can see that over here. Here's the top of that hill, and it's going uphill. So that means we're going to add 20 feet. So B here would be just 20 more feet previous to this. So 100 plus 20 is 120 feet. Now it's sitting right on a contour line, so that makes it pretty easy to determine. We go to the next one, that would be 140. We could also have gone the other way, and on this line, this is 80 feet. But what happens when they're not sitting on a contour line? When they're not sitting on a contour line, what you have to do is interpolate, which means you're just basically giving your best guess. All right. Since C is sitting pretty much halfway in between this contour line and this contour line, we know this is 100. We know this one's 120, which makes this one a good guess of about 110. What you don't want to think of is that it's 100 feet until you get to this point, and then it jumps straight up to 120. This is going to be a gradual change from one to the next. So if it's the same slope, we can assume then it's about 110. Then if we go to D, all right, D is at the center of this bullseye, and just like we can extrapolate here or interpolate here, we can extrapolate what this would be. Well, it's about right in the middle, and as we know, this is 100, this is 120, this is 140, and assuming that it keeps going up, right in the middle would be maybe 150 or so. There's really no good answer or perfect answer, but there are better answers than some. You wouldn't really call this 141 because it's probably not going to just level off when it hits this. One more. Now, hills are like these bullseyes, but if we look at these contour lines, we know that there's obviously something different here. We've got these little hatch lines on there. So if we go up to the actual perspective and see what that is, we can see that if you're walking from the sea up, it's going uphill, uphill, hit that first 200 line, and then we can see that it starts to dip back down. All right, this would be like the caldera or the opening at the top of a volcano that you would normally think of. So it actually goes down towards the center. All right. Same idea though, every time you cross a contour line, you're dropping or increasing 20 feet. But when you see these hatch lines, they're called closed depressions, which just means that if water were here, instead of rolling down a hill, like it does here, it can't escape. It's like a bowl, and it actually decreases by 20 feet. All right, so if we zoom in here for E, we can see we hit 200, and there's another 200 right to it, which means in between is somewhere above 200. Then we start going back downhill. This would be 200. This next line would be 180. So E is somewhere in between. We'll just call that 190. All right, so I think we've got everything we need there. You have same map with different points on it that you're going to find the elevation of, and then move on to the next profile, or excuse me, the next map.